So these are what we would do in class. Usually just work through a few of the brief exercises to just make sure we have everything down. So I'm going to look at brief exercise 6.2. Tony needs the $25,000 in 4 years. How much does he invest today if it earns 12% annual interest compounded annually? So we can go through our 4 questions here. Do we need to know the future or the present? Well, it's how much must he invest today if he needs $25,000 in 4 years. So what we need to know here is the present. Okay, so we need to know the present. We know the future, we definitely. And then we asked, is it a single sum or an annuity? Well, it's a lump sum. There's no mention of equal payments or each year or anything. It's just it's a lump sum. So we would just say single sum. So that gets us to the table, present value, single sum. Number of periods, he needs it in 4 years. It's compounded annually, so it would be 4. And the appropriate interest rate is 12%. Whoops. 12%. There we go. Okay, so to set up the problem, you have to think about this a little bit. The number we're asking, what amount to invest today? So amount to invest today. And sometimes it's easier just to write these out so that they make sense to you. It's going to equal that 25,000 times a present value factor of 4 periods at 12%. Okay? So that's kind of setting up the problem there. So when you you just go look up the factor. Okay, so once you look up the factor, you've got the 25,000. Whoops. Oh, it just has way too many zeros there. There we go, 25,000. And then I'll need the factors there. I'll need all those zeros there, so I've got to put them back. If you're watching the videos on Wiley, this kind of thing doesn't happen because they know how to edit and I don't, so you'll just have to put up with it. Okay, so we go look up the factor and you get 0.63552, okay? You multiply them out, so you get the 25,000 times your factor, and you get 15,888. And then you say, okay, does this make sense? We need 25,000 in 4 years. Does it make sense that we would have to deposit about, 15,888 to get there? And yeah, that probably is a sensible answer, okay? It's really important to do that with these problems because otherwise you can go way off the rails on them. Okay, so now, same problem, but what amount must he invest today if it's compounded quarterly? Okay, so here we still need to know the present. It's still a single sum, so that gets us to that table, present value, single sum of 1. But now, quarterly, you had 4 periods, so now, quarterly, that's going to be 16, because there's 4 periods each year. The appropriate interest rate, 12% per year, but now we have to convert that to quarters. So we would end up with a 3% interest rate per quarter, okay? So when we set up the problem, you basically set it up the same way. Just go over here. You'd have the present value, which is what you're looking for, equals the 25,000 times the factor. So 25 times the factor. Now you have to deposit 15,579. This number should be smaller than the last one because the interest is compounding quarterly instead of annually. So 15,579, 15,888 makes sense. And that's what you want to do. You want to always be checking for, does this make sense? Okay, so I'll do a couple more of these on the next video.